Good morning, students. Today we are going to start with the next unit, that is thermodynamics. What is thermodynamics? It is that branch of physics which deals with the study of transformation of heat energy into another form of energy. Thermal, which is related to heat, right? So here we will study how the heat energy is converted into another form of energy and other forms of energy are converted into heat. Right, student? Heat is converted into other form of energy. Like अगर हम कहें heat energy is converted into mechanical energy. Heat is converted into mechanical energy. Like in engines ऐसा होता है, right? कि heat energy किस में convert होती है? That is converted into mechanical energy of wheel. So this branch is called as thermodynamics. Next is thermal equilibrium. What do you mean by a thermal equilibrium? A thermodynamical system is said to be in thermal equilibrium when the macroscopic variable like pressure, volume, temperature, mass and its composition etc. these characteristic does not change with the time. यानी ये characteristic आपके क्या रहे? Constant. Right. This thermodynamical system consists of a gas, right? And it is in thermal equilibrium if these any characteristic, any macroscopic, because any system is described by pressure, volume, temperature, mass and its composition. If these does not change with the time, then they are said to be in thermal equilibrium. So before starting the thermodynamics, we have to consider two types of walls. Suppose there are two gases which are separated by adiabatic wall. This is a container, right? And at the center we placed adiabatic wall. And the second gas B is placed here. Here the right gases A and B are occupying in the two containers and these two are separated by adiabatic walls. What do you mean by adiabatic wall? Through which there is no transfer of heat. There is no transfer of heat takes place. There is no transfer of heat takes place. So from system A to system B there is no transfer of heat takes place. तो हम two walls पढ़ेंगे. One is adiabatic and second is isothermal. If in the same container you are taking the two gases A and B, but this wall is isothermal. This is a gas. This is isothermal wall. What do you mean by isothermal wall? That is, the heat can transfer from A to B. Heat can transfer from A to B because this is isothermal. Isothermal में क्या होगा? Heat can transfer from one system to another system. This is system A and this is system B. So by using this adiabatic wall and isothermal wall, we will define zeroth law of thermodynamics. What is this zeroth law of thermodynamics? How we define this? According to this law, when the two systems A and B are in thermal equilibrium, according to this law, when two thermodynamical system A and B are in thermal equilibrium with a third system C, means A and B are in thermal equilibrium with the third system C, then the system A and B are also in thermal equilibrium with each other. A is in thermal equilibrium with C, B is in thermal equilibrium with C. तो ऑटोमेटिकली देयरफॉर A इज ऑल्सो इन थर्मल इक्विलिब्रियम विद B. ये स्टूडेंट्स आपको जैसे मैथ्स में इक्वेशन करते थे, A is in thermal equilibrium with C, B is also in thermal equilibrium with C. तो A is also in thermal equilibrium with B. Now to define this, let us suppose एक system लेते हैं in which there are three gases, three thermodynamical system are there. One is A, second is B, and this one is C. And this is adiabatic wall. Adiabatic wall means there is no transfer of heat takes place from A to B, and this is isothermal wall. This is isothermal wall, right, through which the heat can transfer from A to C and B to C. This means through A the heat can be transferred to C. This means A equal to C. B is also in thermal equilibrium with C, so automatically A is in thermal equilibrium with B. राइट स्टूडेंट, तो अब यहाँ हमने कौन सी वॉल यूज़ की, एडियाबैटिक, राइट. तो ए और बी से हीट ट्रांसफर नहीं हो सकती, बट ए इज इन थर्मल इक्विलिब्रियम विद सी एंड बी इज इन थर्मल इक्विलिब्रियम विद सी, तो ऑटोमेटिकली ए और बी क्या हो जाएंगे, इन थर्मल इक्विलिब्रियम. इफ वी रिप्लेस इट बाय, सपोज दिस इज isothermal wall and this is adiabatic. Adiabatic wall, and this is a system, right, A, B, and this is C. It means now this A and B are in thermal equilibrium. Why? Because these are connected through isothermal wall, A equal to B. But A and B are not in thermal equilibrium. A is not in thermal equilibrium with C. B is also not in thermal equilibrium with C, because they are connected through which wall? Adiabatic wall. कैसे connected है? Adiabatic wall, right? They are in thermal equilibrium. Now the heat can transfer from A to B. Once the heat is, because heat always travel from higher temperature to lower temperature. Is it clear, student? So through isothermal wall, these three are in thermal equilibrium. But through this adiabatic wall, only A and B are in thermal equilibrium because they are connected through isothermal wall. So from this zeroth law of thermodynamics, we define one quantity, the physical quantity which determines that the system A and B are in thermal equilibrium that is called as temperature. That is called as temperature because the heat always flows from higher temperature to lower temperature, right? Now ड्यू टू दिस टेम्परेचर, क्योंकि जब टेम्परेचर सेम होगा, थर्मल इक्विलिब्रियम का मतलब हीट फ्लोज फ्रॉम ए टू सी एंड बी टू सी. कब तक फ्लो करती रहेगी? जब तक इन तीनों का टेम्परेचर क्या नहीं हो जाता, सेम. तो फ्रॉम जीरोथ लॉ ऑफ थर्मोडायनेमिक्स विच फिजिकल क्वांटिटी इज डिफाइंड? दैट इज टेम्परेचर, right? This is very important. It tells about the thermal equilibrium. It tells about the thermal equilibrium. Next is internal energy. Internal energy of a gas. This internal energy of a gas is due to, it is the energy possessed by the body or the gas, energy possessed by the gas due to its motion and due to its position. Due to its motion it possesses kinetic energy, and due to its position it possesses potential energy. So total energy is the sum of kinetic energy and sum of potential energy, right? Now for an ideal gas, if I will say for an ideal gas, what is the total energy? आइडियल गैस में हम ये मान के चलते हैं मॉलिक्यूल्स आर इन रैंडम मोशन एंड देयर इज नो फोर्स ऑफ अट्रैक्शन. molecules or atom are in random motion and no force is present between them. No force is present between them. तो अगर फोर्स नहीं है तो पोटेंशियल एनर्जी क्या हो जाएगी इसकी? ज़ीरो, राइट. सो द टोटल एनर्जी इज ओनली ड्यू टू काइनेटिक एनर्जी. टोटल एनर्जी इज ड्यू टू ओनली काइनेटिक एनर्जी. और अगर हम बात करें रियल गैस की, फॉर अ रियल गैस what is the total energy? That is the sum of kinetic and potential energy, because some force is present, so that's why the total energy is the sum of kinetic and potential energy. So this is all about this internal energy. Next is different isothermal processes. What are different isothermal or thermodynamical processes? In chemistry you have studied about this thermodynamical process. क्या होती है थर्मोडायनेमिकल प्रोसेस? फर्स्ट इज आइसोथर्मल प्रोसेस. इट इज दैट प्रोसेस इन विच द टेम्परेचर रिमेन्स कांस्टेंट. It is that process in which the temperature remains constant, right? Next is adiabatic process. Adiabatic क्या होगी? In adiabatic process the heat remains constant. Heat content remain constant. Heat does not flow from one body to another. Heat remains constant. Next is isochoric. In this process the volume remains constant. And next is isobaric process in which pressure remains constant. कौन सी प्रोसेस है इसमें प्रेशर क्या रहेगा? कांस्टेंट. आइसोथर्मल में टेम्परेचर, एडियाबैटिक में हीट, आइसोकोरिक में वॉल्यूम और आइसोबोरिक में बैरिक में प्रेशर रिमेन्स कांस्टेंट. दीज आर द डिफरेंट आइसोथर्मल प्रोसेस. एंड व्हाट इज द गैस इक्वेशन? ऑल ऑफ यू नो व्हाट इज गैस इक्वेशन. Gas equation is PV is equal to R into nRT, right? Next is first law of thermodynamics. What is first law of thermodynamics? क्या है ये फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स? अकॉर्डिंग टू दिस लॉ, whenever the heat energy is supplied to a system, when heat energy is supplied to a system, then it is used in two ways. First, to increase the internal energy, of the system, and second is to do some work. Right? Internal energy of the system, if we say dq is the amount of heat energy supplied, it is used to change the kinetic energy and to do some work. dq equal to du plus dw. dq is the change in heat or small amount of heat supplied to the system. du is the small amount of change in the internal energy and it is the work done by the system. Now sign convention used. आपका whenever heat is supplied to the system, then dq is positive. Heat is taken from the system, dq is negative. ठीक है, heat is supplied to the system, dq is positive. Heat is taken from the system, it is negative. du, if there is an increase in internal energy, if internal energy increases, du is positive, and if internal energy decreases, du is negative. ठीक. Third, if work is done by the system, then dw is positive, and if work is done on the system, then dw is negative. So these are the sign convention we will use in first law of thermodynamics. Next is the applications of first law of thermodynamics that we will discuss in the next video. Thank you.